Got an FM radio kit from Amazon. Paid $4.96 for it. It uses an IC, and that's all I really know about it. I figured I couldn't lose for $5, and haven't opened it up yet. Thought this would be a quick win project. After the last one I did, I repaired an old transistor radio. Let's see what we got here. Got some wires. Looks like a really cheap battery holder. Okay, here's the meat and potatoes of it. We've got a headphone jack. A few electrolytics, some tactile switches. Yeah, and an IC. So I know nothing about this kit really. I didn't read the details. Surely it comes with a schematic. Maybe that's okay, you would think there would be a schematic. Yeah, here's the board. So it looks pretty simple. I mean, it's all through hole except for that IC. I prefer surface mount components, but yeah, maybe this will be a nice little kit. I used to buy some of these when I was in college. When I was 18, 19 years old, I bought some of these really cheap FM radios that had these little tactile push buttons. I remember Walmart sold them. They were about the size of a Baby Bell piece of cheese or something, and I think they took like a watch battery, and they were really cheap. They didn't last, but they only cost like $2. And I would use them for several weeks, and then they would tear up, and I'd buy another one. And I always wondered how they worked back then. I didn't know anything about electronics, but I wanted to. And now I'm obviously learning as I go. So I don't know if I actually want to use the components that are in this kit. I mean, the IC, in the headphone jack, all that stuff I'm fine with. But if there's these capacitors, I may swap these out for like some good name brand ones that I have. If there's any ceramics, I'll probably swap those out because I don't know if those are NPOs. So hopefully, theoretically, using better components would improve the kit. But I don't want to like outsmart the Chinese and then the thing not work or something. So, but yeah, I'll probably won't use these passive components. Probably just use the IC. So anyway, I'll start getting this soldered up and might take you with me when we do the surface mount IC or something, or a couple of the through holes. We'll throw a little soldering point in here. Then we'll check back and see how it works. I'll go get the data set for this IC. I'll try to find a schematic for the radio, and then we'll kind of go through the whole thing, and maybe we can figure out how this works, what makes it tick. All right. I've got the hot air turned on. I'm just going to put some paste on here. That is not sticking too well, is it? Yeah, you're seeing I have a little USB microscope I do this under. And this is just some Mechanics brand paste. Nothing special. Oh, I see the problem. I cleaned the tip with some rubbing alcohol and it's not. Yep. Get that junk out of there. That was the problem. There we go. Now you could do this with, I'm going to use hot air, but you could certainly do this by hand if you wanted to. I really don't like soldering surface mount without hot air, and you can get hot air so cheap now. I mean, they're just dirt cheap. I think I paid $50 for this one. One of the tricks is to keep your airspeed kind of turned down. That way you don't blow, which this is a larger part, so you could turn your speed up a little and it wouldn't move around too much. But I think we got it. Let's check that out. Zoom in where you can see that a little better. There we go. Oh, are we bridged on that side? Yes, we are. Either that or it may just be, yeah, we're definitely bridged. Wow, that's the first time I've actually bridged one in a while, because leave it to me, as soon as I turn the camera on, stuff like that happens. I don't know if it's actually bridged or if those are just pieces of solder that can just need to be knocked out of there. Sometimes you'll have little balls of solder. No, that's... Yeah, I'll get my iron and clean that up. Well, you can choose to believe me or not, but I have never bridged an IC quite that bad before. I just took some solder wick and cleaned it up. So, but ones you see like that, when you clean, they just fall off. So those aren't anything to be concerned about. That's pretty normal. But when you see pins that were bridged as bad as that, you can see a lot of flux on here. I'm gonna have to clean all this up, but you can see things just looks quite a bit better. So I think this will work. But I'm gonna clean this up and get the rest of the board soldered up, and we'll show you what it looks like. All right, I got this guy put together. It was pretty easy to solder. I only took just a few minutes to solder everything up. There's really not that many components here. I didn't end up using 2 of the electrolytics that it came with. I just used some that I had, some better quality ones. Not that it probably matters a lot, but to talk about trying to outsmart the Chinese. So I was going to use some better disc capacitors, but I didn't have any NCOs that are this size, and I don't know if those have to be NCOs anyway. But the first disc capacitor I picked up, the number on it was 103, and so I said, "Wow, that's a really big value. That's like, is that like a 0.1 microfarad or?" So I was trying to do the math in my head, and I thought, man, that's a tiny disc capacitor to. And then I looked at the board, and no, it really, the 103 really meant that it was 103 picofarad. So that's how they're labeled. The 23 picofarad, it just actually said 23 on the capacitor itself. So I thought at first this was like a little fuse, but that's actually a crystal. And then you've got quite a few push buttons, and I mean, yeah, nothing was really challenging, honestly, other than the IC. Now, I did have a problem, and this won't come as a shock to you after seeing the poor soldering job that I did, but when I put everything together, it worked, but the right channel did not work, and actually had the 2 pins for the left and right channel. They were bridged, a very, very tiny solder bridge that I didn't remove when I fixed that. Oops. So I just bumped it with a soldering iron, got that bridge out of there, and both channels are working great. I didn't expect much from this kit. I mean, for $5, it has no external antenna, but let me tell you, this thing performs. And the other shocking thing is the IC itself is very intriguing. So to operate it, you're supposed to zip tie this to the underside of that, but I didn't want to do that right now. So, but this is your power button, and then you hit these to seek. And I don't know how well you're going to be able to hear this. Probably not at all, but just make sure I got the volume all the way up. The reception is very, very good. I mean, it's digitally tuned. It seeks from one station to another. That's station up, station down, volume up, volume down, and then power. And it never starts on a station. When you power it up, I don't know, there's some kind of default frequency, so it kind of just goes back to home base every time. But the really intriguing part is the IC itself. So I kind of expected it to be like a really cheap, and it is cheap, but I expected it to be some sort of, honestly, some kind of Chinese garbage is what I really expected. And this is a pretty popular IC that I had not heard of. It's made by RDA. It's the RDA5807FP. And the data sheet is a little bit hard to read because it's kind of reads like it was ran through some Chinese to English translation software, so the grammar is pretty tough. And honestly, some of the functionality of it is not covered in very good detail, which I'll go over in a second. But this little IC is, I mean, maybe I'm just easily impressed because I was born in the 80s where there really wasn't this kind of technology, but it's pretty impressive to me. So going over the block diagram on the inside of this thing, you've got your FM signal antenna coming into a low noise amplifier, and then part of that is connected to, they're calling it a limiter. I guess another name might be a attenuator. This is to prevent adjacent stations from walking on top of each other. And then you'll see it goes into, I'm assuming there's 2 or 3 IF stages, maybe. I don't remember if the data sheet even says. And then down here you'll see there's a voltage controlled oscillator that's connected to this. I'm assuming this is kind of like an analog mixer circuit here. And then you've got a synthesizer connected to this R clock. And the power supply, it has a low dropout voltage regulator built into it, which I thought was pretty cool. But that, I mean, maybe that's just kind of standard for this sort of thing. And then there's a PGA, and then analog to digital converter, and then you've got your digital signal processing. This thing supports quite a bit of functionality that little board doesn't have. So this is where things kind of get interesting. It supports RDS and RBDS. I don't know what RSSI is, but what these are, this is the extra digital information that can be transmitted with FM stations. So it might tell you the name of the artist, the name of the song, that sort of thing. And so this little IC supports all that stuff, and it supports bass boost and all kinds of functionality that, again, that little board does not have because it doesn't have a microprocessor. So there's an interface bus, and it supports I2C, and the frequency of this clock line is 32.768 kilohertz, which you can see, and that's the crystal that came with the kit. The little bitty round silver crystal is a 32.768 kilohertz crystal. So that's how that clock speed gets there. So yeah, very, very interesting and feature rich. And again, the reception is just, I mean, to be so small, it is absolutely phenomenal. I mean, it's picking up every station in this area and very clearly. And even some of the weaker ones, you would think that it would just, because it's digitally tuned, you can't, in this simplistic mode that it's operating in, you can't purposefully put it on a particular frequency. It just has to automatically find the next strong station. Well, it doesn't even really skip over the mediocre stations. It will stop on the slightly weaker ones, and it'll be just a little bit staticky. But yeah, it's just really, really impressive. The I2C functionality it's pretty rich, and I work as a computer programmer, so I'm usually pretty good at reading documentation and stuff. And I read through the documentation for in this this data sheet for the I2C bus, and it is very difficult to understand, honestly. But it has a lot of functionality. If you have a microprocessor on paired up with this thing, you can read the station that it's tuned to. You can read whether it's in stereo. You can read. There's a whole bunch of other things. I don't even remember the big list of things. So it's not just inputs, but it has outputs, and you can see that if you look at that pin out one more time, you can see there's general purpose input output pins up here, and that's what those are used for. That's for the I2C bus. And I actually looked online, and there's an Arduino library for this thing that will really make it sing and dance. So you can do so much stuff, especially with an LCD display. It's just a really, really cool IC. And if you follow this thing down, it kind of gives you it sort of goes over some of the I2C, the registers here, but again, it's not. I don't consider this to be super good documentation, but the I2C documentation part isn't. It's not too lacking, but what is lacking in the documentation? So I read over it several times trying to figure this out, and it's just not in there. It tells you how to use I2C to change the stations and to reset, read the frequency, set the frequency range. Oh, that's another thing. This IC supports, it's for international use. It goes all the way down to 50 megahertz and all the way up to 108 megahertz, and it supports all the different stepping modes that you would have. As I think in Europe and Asia they have a different stepping than we do here in the United States. So it supports all that stuff. So it's but they back to what I was saying. They don't tell you how that it would be configured with just simple push buttons, and it's not. I mean, I've read the documentation over and over. I cannot figure it out. And so I just started to do continuity checks to see where these push buttons go. And they go to these pins that, again, I just don't completely understand it, but it goes to, one of them went to SDA, one went to R clock, and those should be used with I2C, but obviously these little push buttons, this is not I2C. I mean, there's no microcontroller here, so there can't be any I2C present. So I think what they have is some sort of default functionality to just pull those pins high and low with some push buttons so that you can get basic functionality out of the IC without the need for a microprocessor. But I was so intrigued by this that I actually ordered a 10-pack of these of this IC from China, of course, on eBay. I think it was $7 and something, $8. The shipping was insane. The shipping was $6, but the ICs for a 10-pack, I think, or maybe it was a 5-pack, it cost $1.90. So that's the other thing is, not only does it have a ton of functionality, but they're really cheap. But the odd thing is I could not find them for sale on any electronics supply website that I went to. I checked LCSC because that's where I normally order from. I checked Janeco, DigiKey, all of them, and none of them have that IC in stock. And I find that to be really odd. And the other thing is, again, the data sheet kind of seems like it might be missing some important things in there, and it's marked confidential. So I almost wonder if this thing it's been leaked from RDA. Maybe this, and again, I really don't know. I'm just kind of guessing. Maybe they designed this to be sold commercially only through maybe like an NDA or something. I don't, again, I really don't know, because you would think something like that seems to be this common, that, again, there's an Arduino library for it that's a very rich, well put together library. I read through it. You would think these things would be sold everywhere. But the only places you could find it is like eBay and Amazon. So anyway, I didn't measure the current. I would be kind of interested to know how much power it uses. At first, I accidentally had put AAAs in there because they fit kind of loose, and I thought, well, that's odd. But when you put AA's, this battery holder, man, it's cheap made. Very thin, flexible type plastic, but they're not coming out of there. And you could zip tie this to that, which is what you're supposed to do. It even comes with the zip ties. Or you could print like a 3D enclosure, and you could take this thing out and actually use it. I mean, it's very usable. It's not just like a toy type thing, like what you would think from just the way it's advertised and being as cheap as it is. But no, this is a real full-blown FM radio that, in my opinion, is, I mean, this is something that you could go jogging with, or take camping or whatever. Like, it's just that good. I guess if I had to say one negative thing, is that 3.3 volts that the IC requires. So you're kind of stuck with double A's or triple A batteries. If you wanted to design a circuit board for this yourself, you could do 18650 battery or a 9-volt battery. So the ones that I ordered, I'm going to design a circuit board, and I think I'm going to go with an 18650 battery because they're rechargeable, and I've got quite a few of them laying around. So I would rather have, which I have rechargeable double A's too, but I would rather have something like that that's USB rechargeable, and than to mess around with these. And it would be smaller and lighter with an 18650 battery too. But yeah, when the ICs come in, I'm going to build a little circuit board and probably use a microcontroller and an LCD display to get some really cool functionality out of this thing. Anyway, I hope y'all enjoyed the video, and I hope this helps somebody else out. If you're wanting to build one of these kits, then I would say you can't go wrong for $5. I mean, it's just, even if you screwed it up, they advertise it for soldering practice. I mean, like, it's totally worth it for $5. And also, and maybe if you're kind of new to soldering surface mount, you see that I done it with the hot air, but honestly, this is a pretty big surface mount device, and you could do this with a regular iron, and it wouldn't be that difficult. And the way you would do that is you would put a dot of solder on one of the corner pins, and then scoot the IC over, and then use your iron to kind of tack that one corner. And then from there, you could just drag some solder down it. That's the drag method is what I kind of see the most. But there's lots and lots of YouTube videos that'll show you how to solder that without hot air. But anyway, well, thanks for watching.